exponent, whoops, exponent, and then I ask myself, what's left? What is left? And what is left is the argument. So I wanted to, that's how I go about doing these problems. Base, exponent, what's left? So we want to rewrite as a logarithmic equation. Now, if it has logarithmic in it, you definitely want to write down a log, L-O-G. Then we want to look over here. We first want to find the base. That would be 4. That would be 4. That base goes in the basement a little bit, down off the normal line of writing. Then we want to find the exponent. The exponent is 3. Now remember, the entire logarithm is an exponent. So that exponent goes on this other side because this entire log is an exponent. All 3 pieces, the LOG, this base 4, and the 64, they're all part. This is all one real number right here. This represents all just one real number here. This entire left side represents one real number. So the exponent of 3 goes on the other side. The exponent of 3 goes on the other side. And what's left is the argument. What's left is the argument 64 that goes right here on the normal line of writing. So that's all you need to do to rewrite this as a logarithmic equation. Now going the other direction, you can still use the same process, which is what I like about this base, exponent, what is left. So we want to rewrite this as an exponential equation. We want to find the base. The base is what's in the basement. Or it's the base here of this exponent. But in this case, this base is what's in the basement. It's 6. 6. Now, this 6 needs an exponent. We want to convert to an exponential equation. If I read that wrong, but I read it wrong to get my point across, it has the word exponent in it. We need to put something in the exponent if we're rewriting it as an exponential equation. Remember, the entire log is an exponent, all pieces. So this entire log here is an exponent, and that entire log is -1. That is the exponent, -1. That goes up here. Equals what's left. What's left is this number 1/6. So we'll put it on the other side because we need something to put over here. So that's how you can convert between logarithmic and exponential equations. I think we're going to do one more of these, one more question in the same topic. Any questions on this particular question? Remember, base, exponent, what is left? You might want to jot that down if you haven't already. Base, exponent, what's left? I'm jotting it down real fast here. Okay. Converting between logarithmic and exponential equations. Same topic, different question. Rewrite as an exponential equation. That means we're going to have a variable in the exponent. So we are going to use base. What's the base? That's what's down here off the normal line of writing. That's the base of this log function here, which is 2. Next, the exponent. An entire logarithm, all 3 pieces, is an exponent. So our exponent is 5. So this would be 2 raised to the 5th power equals, what's left? This number 32, normal line of writing. That's all they're asking you to do, convert between logarithmic and exponential equations. They're not asking you to solve them or anything like that. They're asking you just to convert them. And please ask questions because I want to make sure you understand. Part B, so that's the answer to part A. Part B, rewrite as a logarithmic equation. So we want to do base. The base here is the bottom of this exponent. The bottom of this exponent, which is 7. And we need to start with, since it says rewrite as a logarithmic equation, we need to start with a log. We need to start with an log here, an log. You need to start with a log, and then we need a base, which is this 7, which is the base of this -1, the base of this exponent, which is just 7. That goes in the basement here a little bit. And then the next thing is exponent. What's the exponent? And the entire logarithm is an exponent. The exponent is -1. The entire log, all 3 pieces here is the exponent, so that -1 goes on the other side. What's left that we haven't used? This 1/7 goes inside as the argument right here. Any questions on, and that's the answer. That's what Alex wanted. That's the answer. Any questions on converting between logarithmic and exponential equations? So let's take a look at converting between natural, logarithmic, and exponential equations. Slightly different topic here. Now we're going to talk about natural log equations. So a natural log equation, now let me just write this out for you. It's lowercase l, then n, lowercase n, x. What does that really mean? If I wrote it out the long way, it would represent log, really means this, log base e of x. That's what it means. That's what it means. That e is a non-terminating, non-repeating decimal. And I don't want to risk marking that up and making it. I wanted to make the line go all the way across, but I don't think we need to do that. So it's important to know that to do this problem. Converting between natural logarithmic, and exponential equations. Rewrite each equation as requested. Rewrite in part A, rewrite as an exponential equation. That means the variable is in the exponent. The variable or number is in the exponent. So we have ln of x equals 3 is what is given to us. So how do we write out that ln of x? That ln of x is really log base e of x. This ln of x is really log base e of x. So I put log base e of x equals 3. I'm just rewriting the given problem so I can figure out what to use for what. So we want to do the base first. The base is E. It's down off that normal line of writing a little bit. The base is E. That's a non-terminating, non-repeating decimal. This E is a number. Then, so we found our base, which is our order. Then we need the exponent. This entire log here, all three pieces, is an exponent. So our exponent is this, 3, equals what's left. We haven't used this x yet, so that's what's left. So that's the answer to part A. E to the third equals x. E to the third equals x. This is the answer. Anybody have any questions on part A? Part B, rewrite as a logarithmic equation. So first of all, since it says logarithmic, we know we are going to need an log. It's right there reminding us this log here. So we write down log. So the first thing we want is the base. The base of this exponent is E. We put that base in the basement of the log function here, if you want to think of it like that, down off the normal line of writing. We next need to find the exponent. The exponent is y. Now we're talking about a log here. So an entire logarithm, all three pieces, is the exponent. So that means this exponent of y is going to end up on this other side. And what's left? We haven't dealt with this 6 yet, so the 6 is what's going to go in here. What's going to go in here? We can write this. Alex I would have to check to see if they'll take it like this, but log base E of x is just ln. So this ln is really log base E. So we could take out this log base E here and replace it by ln, which stands for natural logarithm. E occurs in nature a lot, so that's why it's natural in the wrong order, N for natural, L for logarithm, but that's why it's called the natural logarithm, because E comes up a lot in nature. Any questions on this? So this answer is ln 6 equals y. I would hope that Alex would take it either way. I haven't ever looked at that specifically, so I'm not 100% sure. Any questions on this topic? So I'm going to cross off that one on natural logarithmic and exponential equations. And let's just take a break for a little bit and let's talk about our participation question. But before I do that, yeah, so and I need to go to the same place to do both. So I would just want to re-go over these announcements just to make sure everybody has heard them. Spring break is the official dates according to the college are 3/21 through 3/28. So that's a week. You have an objective due tonight and an objective due this Sunday. If you want to finish it before Sunday, you can, so that you have your spring break during the official time. Some faculty are giving students work to do over spring break. I'm not giving you any additional work to do over spring break, except for what's due on Sunday, which you can complete earlier. I am by no means requiring you to do this, but if you want to get some more points for your past due objectives, there will be 5 or 6 days of open pie mode during spring break where you can go back and work on past due objectives. You can also work ahead in the course if you would like. That's what open pie mode means. To put it in perspective, we have 5 weeks of class after spring break and then comprehensive finals. In math, we are required to give a comprehensive final. And in math, every math class has assessment questions on it, or every math comprehensive final has assessment questions on it that are decided upon by our department. And I don't know what the assessment questions are for this spring yet. I have no idea. So those are some announcements. But I wanted to have a little fun today, and as I know spring break is coming up, and I want you all to stay safe and healthy, of course. And I would just like to know, and I think other students will enjoy this too, what are your spring break plans? What are your spring break plans? I think I already mentioned today my spring break plans are just enjoying time with my family. I have 2 daughters, 9 and 17, and they love to cook. So, and we help each other learn how to cook, and it's a lot of fun. We like to play cards. We enjoy going outside. We enjoy coloring with the colored pencils. We enjoy doing crafts. We enjoy doing a lot. So we're going to have some fun. Going to Mexico. Wow, that sounds like fun at a summer camp. Spending time pitside. Getting caught up on all my classes and hang with my friends. Going to Alabama. Working, Alejandra. I hope you get some time to rest and rejuvenate. I'm going on a road trip through Tennessee and Georgia and all the way to North Carolina, just making a couple stops in the States. That all sounds like fun. I'll live vicariously through all of you. Yeah, but I really need some good quality family time. My 17-year-old she's going to start her senior year in the fall, and so I've got to rejuvenate because we've got to figure out what our finances for college for her and so forth. We got a lot to do, but I don't want to do it quite yet. I want to just relax over spring break. So that's good. No downtime, just overtime. That's funny. I love Alejandro, how you put that. That's funny. Hoping I win my bets on March Madness. Anyone else going to Texas? Well, you all have some plans, that's for sure. Sometimes I watch March Madness, but I haven't been watching too much sports since the pandemic started. I try to watch the Cubs. I grew up in Chicago. I love the Cubs. I used to, even when I was 10 years old, I used to score the Cubs games. And I love the Cubs, but it's not the same now. I miss the fans in the stands. I don't know what they're doing now, and I want to check on this because now that the COVID vaccines are available, I wonder if they've all been vaccinated. I have to look into that. Anyway, we better get. Go ahead, Austin.
The Rangers had their first full capacity game with mask. I think it was 2 weeks ago.
Oh, I see. Yeah, I don't know how that that goes down. I mean, I am very conservative when it comes to COVID. We have not gone into any stores since COVID's happened. We go pick up our groceries, basically. We order and pick them up. We go into my girls go to the dentist when they need to. They go to the orthodontist. The older daughter is had on her second round of braces. I go get my allergy shots, and so does my younger daughter. But we don't really go out. We don't go and eat. We've eaten all our meals in the house, and that's unusual for us because we used to go out to eat quite often, but we haven't done that in a year. And yeah, we're just very careful. My husband has got a couple underlying conditions that would put him at more increased risk, and we're all virtual in this house. So anyway, I just be careful out there and take all necessary precautions because COVID is still not, we still have a lot of COVID in this country right now. So let's go down to my desktop and let's finish up. We've got 2 more topics to talk about today. I might let you out a little bit early today. Let me get to the right place. So let's take a look at this topic, evaluating. In other words, find the value of has a number. That's usually what that word means in math, evaluating. Logarithmic expressions. So let's see how we can use this all important. Let me go back up here to our formula sheet. This is what we want to use here. We want to get these, you see how this base of the logarithm matches the base of the exponent? We want to get these bases to match. Because when that happens, the answer is just the exponent because a log is an exponent. So we want matching bases. A log is just an exponent. And when we have matching bases, it's the exponent that we see up here or is understood. It's possible to have the number 1 understood. So that's what we're looking at right now. That one. Go back here. And let's see. I remember where I am. I go all over the place. Did that one? Here we go. So this one, evaluate each expression. In other words, find it as a number. Find its value. Values in here. Log base 7 of 7. Now, if we write this out here, we can write it as log base 7 of 7. This 7 is really 7 to the first power because it's only 1 7. So we can write that to this 7 here to the first power. So we have the base of the logarithm is 7, and the base of this exponent 1 is 7. When these bases match like this, the log is just that x up here in the property we just looked at, which is 1. So the answer is 1 here because the bases match. This answer is 1. So let's look at part B. Part B. Log base 3 of 1 over 27 equals. How in the world did I get that -3? Well, let's see what we can do. First of all, I would take 27 and break it down into its factors. So I made a factor tree for 27 here. 27 is 3 times 9. 3 times 9. 2 isn't going to go because it's odd, so 27 divided by 3 you could do on your calculator and you would get 9. So we can write 27 as 9 times 3. This 9 we can write as 3 times 3. So 27 is 3 times 3 times 3. 3 times 3 times 3. Now what do? Well, we have a property of exponents that we can use. The property that we're going to use is what happens if we flip this to the denominator. So this is really, to be precise, this is 27 to the first power. That's 27 to the first power. No, wait. No. I didn't look at that other side. Let me get rid of that. I don't want to put that there. Okay. Don't want to put that there. So let's look at it from this perspective. 1 over 27. We want to take that out and replace it by something. 1 over 27. 1 over 27 is here. 1 over 27 I put right there. I'm just looking at the argument. I put that argument of 1 over 27 right here. I put a 1 there. Put a 1 there. There wouldn't have been any harm in putting it there. I just didn't want really, that wasn't my point though. Equals. Now, we can bring this up to the top. When we bring this up to the top, the only thing we are going to change is the sign on the exponent. That's one of our properties. It's b to the negative m in column 1 equals 1 over b to the m. We've got b to a positive number here, 1. We can bring that up to the numerator where we have exactly the same base, 27, but all we do is change the sign on the exponent. It's 1 here. When we bring it up, this 27 up, it's going to become, we're going to change the positive to a negative. And we're still going to have this 1 here, this number here. The only thing that changes is the base doesn't change. This number doesn't change. The sign of the number changes, though, from positive to negative. So this 27 here, that is really 3 times 3 times 3, which we could write as in shorthand as 27 equals how many 3's multiplied together? 1, 2, 3. 27 is 3 of these 3's multiplied together, so we can write it as 3 cubed. So I'm going to take out this 27 and put in 3 cubed in its place, still raised to the negative 1. Now this is a power raised to a power. We've got an exponent property for that. A power raised to a power. So what we've got here is b to the, in the first column, it's the 1, 2, third one down, b to the m, all raised to the n, equals b to the mn. That means all we have to do, m times n. mn is m times n. And so all we have to do is multiply these two together. 3 times negative 1, that gives us 3 here, gets copied down. 3 times negative 1 is negative 3. So power raised to a power, you multiply the exponents. 3 times negative 1 is negative 3. So 1 over 27 is 3 times negative 3. So 1 over 27, we're going to take out right here and replace it by 3 to the negative 3. This base stays, this 3 stays. Then this 127, 1 over 27, we replaced it by 3 to the negative 3. That's these guys up here. What that does for us is it gives us a matching base. The base of the logarithm is 3. The base of the exponent, the base of this exponent here is also 3. Those 3's match. When you're taking the log and the number in the base of the logarithm matches the number in the base of the exponent, then the answer is this -3. Remember, an entire logarithm, all the pieces of the log, is an exponent. And when the bases match like this, it is the exponent you see. It is -3. That's the answer for part B. You must have matching bases to do that. If we had a 3 here and a 4 here, we couldn't do that. It wouldn't work. Have to have the bases match. Any questions on this? So that's evaluating logarithmic expressions. Let's take a look at another question in the same topic just so we get some more experience with this. Evaluate each expression when a logarithm is written log without an explicit base, and it refers to the common logarithm, and that means base 10 is understood. The common logarithm is log like this, log. The base is not written in, it's understood to be base 10 now. Base 10. And maybe I should write that down for you. So I'll take care of that. So let's just look at part A first. We want to evaluate this expression right here, log base 4 of 64. So let's 4 down. Now we're trying to get this 64 to have 4's in it so they match. So it makes sense to try taking 64 on your calculator and dividing it by 4. So 64 divided by 4 is 16. So 64 is 4 times 16. 16 is 4 times 4. So we can rewrite this 64 as 4 times 4 times 4. That means we have 3 4's multiplied together. 3 4's. 3 of these 4's multiplied together. So now we can we can write down log base 4. This 64, we can rewrite it as 4 cubed. Now this 4 is down a little off the normal line of writing. When we put in this 4 here, it's going to be on the normal line of writing. And then this exponent 3 is up off the normal line of writing a little bit. What you will see now is we have a log and we have matching bases. 4, the base of the log, matches the base of the exponent. So in that case, when we have matching bases, the log is the exponent you see or is understood, and that is 3. So this answer here is 3. So let's take a look at part B here. Log 1/10. So let me just clarify something for you. This really means log you see there's no base written in here. There's no base of this logarithm. This is what we call the common log. When we have log, it's got to be log, and there's no base written in. It's understood to be base 10. It's understood to be base 10. It's a common log. And we work and it's called the common log. We work in base 10 in this country. So that's how you can remember that. We talk about numbers where we're using base 10. So, and then this is 1/10. on the normal line of writing, the best that I could there, equals -1. So perhaps I can clarify this a little bit better so you can see that this is 10 right here. Let me see if I can do that. I want to make sure you can all read it too. So this is 1/10 there, normal line of writing. So that's what we're dealing with. So I didn't see it, that I noticed that I had it written here. Log base 10 of 1/10. That's the common log. Log base 10 are called common logs. Log base 10 of any argument is called a common log. So what do we want to do? Well, we want to get the bases to match. So we have this base 10, but the base of, there's an understood 1 up here, so you can consider this the base of that understood 1. This is in the denominator. We need to get it up to the numerator. Now we have a property of exponents, which allows us to bring it up to the numerator. So we can bring this 1/10 up to the numerator. What does that property say? Well, we can move we can move a base to an exponent from top to bottom or bottom to top, and the only thing that changes is the sign on the exponent. So we can bring this 10 to the first up like this. The 10 stays the same, this 1 stays the same. The only thing that changes is the sign on this exponent. It would change from positive to negative when it comes up. So this comes up as 10 to the -1. So we can take out this 1/10 here and replace it by 10 to the -1, where the 10's on the normal line of writing and this exponent of -1 is up a little bit. And this is a 1 here, and I don't know how clear you can see that. So I'm going to put it in there. So now we've got this base 10 of the logarithm, this base 10 of the argument match. A log is an exponent, and when the bases match like this, it's the exponent we see here, which is -1. So the answer for part B is -1. Any questions on this particular topic? We looked at 4 separate problems in this particular topic. Evaluating logarithmic expressions. Cross that one off. So we have one more topic to go. It is graphing a logarithmic function basic. Now we looked at graphing a exponential function on Tuesday, and we found out that the asymptote was always the x-axis. We are now going to graph logarithmic functions, and it turns out that the asymptote is always the y-axis for this topic. So you might want to jot that down. I don't know that Alex is writing it out like that to be very precise like that. I think not. And Alex is using, I believe, 5 x's for this problem, and we only really need to use 2. But on the explain page, they are using 5 points. We're only going to use 2. We're going to just pick our points very, very strategically. So we want to graph f of x equals 4 times log base 2 of x. To graph the function, plot at least 2 points on the graph, draw all asymptotes. There is only one asymptote, and it is it is always, for this particular topic, it is always the y-axis. And the y-axis, you would use the vertical dashed line. And then click on the graph icon. So what two numbers are we going to use? The answer, we're always going to use the number 1. This is what I would recommend. And you want to use the base as well. So we want to use 1, and we want to use the base. What's the base here? The base of the log. It's 2. Whatever the base of this log is 2. The reason why we're going to use the base here, because we're going to take advantage of matching numbers here, just like we did in the last example, or the last topic. That's why we're picking these two. So you might want to jot down, you want to always use the number 1, and you always want to use the base. The base is what's at the bottom of this, the bottom of the log here. It's in the basement a little bit. It's 2. It's 2 in this problem. So then we want to figure out what the corresponding y coordinates are. So our function is 4 log base 2 of x. F of x equals 4 log base 2 of x. So we want to plug in. So we want to take this 1 and plug it in here. That would give us 4 log base 2. 1's going in for x here. 4 log base 2 of 1. Now, if you look on your formula sheet that I wanted you to copy down, you will see that the first entry in properties of logarithms is log base b, log any base b of 1 is 0. So this is 4. This log base 2 of 1, that's log base 2 of 1. Log any base of 1 is 0. So this whole thing here, right here, this log base 2 of 1 equals 0. So this is 4 times 0, which is 0. So the answer is 0 here. So that's the reason why you want to pick 1, because log any base of 1 is 0. Now, the other one we picked was to use the base. The base for this particular question is 2. So let's start here. 4 log base 2 is from here, and then we're plugging in 2 for this x on the normal line of writing up here. Now you notice we've got let's copy this over so I can show you something. So this is 4 times log base 2 of 2. But this 2 right here is the base of the exponent. It's the base of the exponent 1. We could put a 1 in there in the exponent. This 2, the base of the log, and this 2, the base of the exponent, match. When they match, it's the exponent you see that or is understood, which is a 1. So now this is 4. All of this right here, because of the matching bases, turns out to be 1. So we multiply these two together. This is 4 times 1, and it turns out to just be 4. So we can go and just plot those 2 points. 1, 1, 0, right there, and 2, 2, 4. Start at 0, 0, go over 2, and up 4. And that would go right here. And of course, you've got to draw your vertical asymptote on the y-axis here. Any questions on this particular problem? I think we're going to do another one. Always use the number 1 and always use the base. Keeping in mind that You want to draw your vertical asymptote on the y-axis. So let's take a look at this one. Graph g of x equals -4 plus log base 1/2 of x. So we're still going to choose 0, and we're going to, wait a second, let me see. We want to choose 1. We want to choose 1. Yeah, we want to choose 1. I guess I was thinking about the asymptote. We want to choose 1 for sure. Choose 1, and we want to choose the base. We want to choose the number 1 and the base. Another way to look at it. You could write it like that if you want. So the number 1 makes sense. We want to choose our base, which is here, 1/2. 1/2. And we want to plug them in to the original function, which is -4 plus log base 1/2 of x. And I wrote that right here. So if we plug in 1 here, we're going to get -4 plus log base 1/2, and we're taking this 1 and plugging it in for x, so that will give us a 1 here. So that's -4 plus log any base of 1. That's that first property in the logarithms column. Log any base of 1 is 0. So this is plus, this whole thing here is 0. So this is plus 0. So we get -4 here for our answer. So we want to plot this ordered pair, 1, -4. Here we chose the base. The base is 1/2 here. And we're going to plug that in. So we get -4 plus log base 1/2. I squeezed it in there, that 1/2 of x. What's our x? We chose our x to be 1/2 on purpose, so we would get this matching occurring. And we can put the exponent of 1 on this 1/2, just to be clear about what the answer is. A log is an exponent, and when the base of the log and the base of the exponent match, it is this number here that is understood, or you see, in this case, it's 1. So for this term, it's just plus 1. So we get -4 plus 1, which is -3. And that's the answer here. So I didn't get the graph of this one, but you want to plot those 2 points. You want to plot 1, -4. So that means we would go over here 1 and then down to -4 and plot a point there. And we want to plot this point, and you can do that with the plot a point anywhere tool in Alex. That would be 1/2 -3. You go over to 1/2 and down to -3. And then you draw your asymptote as using this dash vertical line here. You click on that and you just draw that here. And then you click on this graph tool. So that should be enough to do it. So this is really all that I have for you today. Does anybody have any questions on what we covered today? Anybody want to copy down the properties of exponents of logarithms? Anybody need anything? So I know I owe you some minutes, I'm sure, from earlier on in the semester. And I wish you all a very fun-filled, safe, and happy break. Take care, and you're welcome to stick around and chat if you need to talk to me about anything.
Thank you.
You're welcome.
Thank you. Have a good one.
Thank you, Alejandro.
There.
Thank you. Bye for now. I'll see you in like a week and a half.